Hi, boys and girls. Today we are going to be working with the commutative property of multiplication. Now, if you remember, we had a commutative property of addition that told us that we could add two numbers in any order and we would get the same sum. It's very similar in the commutative property of multiplication. This property tells us that we can multiply two factors in any order and get the same product. So I'm going to show you today how we use arrays and pictures to help us solve these problems and to be able to show an array in both ways in the commutative property. So we have a multiplication word problem here. Dave works at the bird store. He arranges 15 boxes of birdseed in rows on the shelf. What are two ways he can arrange the boxes in equal rows? So we're going to make an array. Now, if you have your math manipulatives at home, please take out your counters and you can make the array for yourself on your table or desk. I'm going to draw the array here on my page. So you can do the same thing in your workbook on page 171. Okay, so if he has 15 tiles and we want to arrange them in 5 equal rows, rows go from left to right. So if I want 5 equal rows, I want to make one column of 5 counters. And then I'm going to continue making counters until I count up to 15. So I have 5 here, and each one of these counters is going to make its own row. So I start with 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So now I have 5 equal rows, 1, 2, 3, 4, 5, and I have a total of 15 counters. Now I have to decide how many are in each row. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So I have equal rows, and there are 3 counters in each row. So I will put here 3. Okay, so we have 5 equal rows, 3 counters in each row. What multiplication sentence will go along with our array? Well, just like we would do 5 groups of 3, 5 jumps of 3 on a number line, in an array we have 5 rows of 3. And we write that as 5 times 3, 5 groups of 3 equals, and our total number of counters was 15. Okay, so I have an array, 5 rows, 3 counters in each row for a total of 15 counters. Now, if Dave decides to arrange his boxes in a different way, he still has the same number of boxes. He still has 15 boxes of birdseed, but now he wants to arrange the boxes in 3 equal rows. So just like we did up here, we're going to create our 3 equal rows. So we start and we make 3 counters in a column. And then we're going to continue making columns of 3 until we've counted up to 15, just like we did here with our 5 rows. We're going to do the same with our 3 rows. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So now I have 1, 2, 3 equal rows, and I've used all 15 of my counters. Now I need to decide how many tiles are in each row. Well, I used the same number of tiles, right? I used 15. I now have 3 rows And there's 1, 2, 3, 4, 5 tiles in each row, or 5 counters in each row. So now instead of 3 tiles in each row, we have 5 tiles in each row. Now we have 3 rows of 5. So our multiplication sentence is going to change. We're now going to write 3 rows of 5 equals, and it's the same number of counters. We still have 15 counters. Now I have 2 multiplication sentences that include the same 3 numbers. We have 5 times 3 equals 15, and we have 3 times 5 equals 15. This shows the commutative property of multiplication because we've only rearranged the order of the 2 factors and we've gotten the same product out of both. 5 times 3 equals 15, 3 times 5 equals 15. We may also see this written 5 times 3 equals 3 times 5. Any way that you write it, it's showing that the factors are just flip-flopped, but we get the same product. Now it's your turn. Go ahead into your slides and follow the directions for how to create arrays and multiplication sentences that show the commutative property.